Lalita Singh and you are going to study science with me in class 7. Today we are discussing second part of chapter 15, that is called electric current and its effect. Okay, in this chapter, in our previous video, we have learned about electric current, electric circuit, about the component of electric circuit, about their symbols, and we have also discussed about heating effect of electric current. We have seen the use of heating effect of electric current in fuse, which is a safety device, right? And we have learned about miniature circuit breaker, yani MCB as well. Okay, now we have to talk about magnetic effect of electric current. Magnetic effect means when due to passage of electric current, when an object is behaving like a magnet, this is called magnetic effect of electric current. Understood? It may be sound like astonishing, but still, whenever the electric current is passing through a wire, maybe behave like an electric current. To show this, just we have to perform the activity number 3. Okay, to show magnetic behavior of conductive wire on passage of electric current through it. To perform this activity, we need a magnetic compass. Okay, a piece of copper wire, a cell, a switch and connecting wire. Okay, now just perform the activity. We will take a magnetic compass and we will place it on the table. Allow it to come at rest so that needle can be at rest. Okay, now take a straight copper wire about 10 to 12 inches long and keep the wire parallel to the compass needle. Now connect the wire to its two ends of the cell and switches to complete the circuit. Just see over here, we have placed the wire parallel to the needle of the magnetic compass and now we have completed the setup. Okay, now we will switch on and observe what changes are shown in the needle. As soon as the current is flowing through the circuit, as we have connected the two ends of the wire, the needle will show deflection. On turning the circuit off, the compass needle get back to its original position. This is show the magnetic behavior of the wire. This is showing the magnetic behavior of the wire, because as the wire is acting as a magnet, the magnetic needle will show deflection because of the attraction and repulsion appear during between two magnets. Okay, now class, in activity, when the circuit is switched on, the compass needle show deflection, and when it is switched off, the needle is going back to its normal position. This is because when an electric circuit is having current through it, okay, when the current is passing through the electric circuit, it develops a magnetic field around it and behave like a magnet. Thus, the phenomena of developing a magnetic field around a wire by passage of electric current through them is known as magnetic effect of electric current. The combined effect of electricity and magnetism is known as electromagnet. Okay, when we are making something magnet just due to the presence of electricity, okay, this will be known as electromagnet. The magnetic effect of electricity was first noticed or studied by Danish chemist and physician Hans Christian Ørsted. He laid the foundation of electromagnetism by showing that there is a distinct connection between electricity and magnetism. Okay, now the question arises, what is magnetic field? Magnetic field is an area around a magnet. Either it is temporary or permanent, does not matter. The area around a magnet where magnetic force is effective. It means in that area, if you will place a magnetic substance, it will get attracted toward the magnet. If you will place similar pole of a magnet, then they will repulse each other. Understood? Now, application of electromagnetism. Electromagnet is a solenoid with a soft iron core. Now, what is solenoid? A cylindrical coil of wire acting as a magnet when carrying electricity, like this. Okay, this is what a solenoid, or we can say this is what a solenoid. Okay, so when a cylindrical wire is having wrapped up wire, when a cylindrical metal or anything which is having a wrapped up wire, they are acting as a solenoid. Okay, so An electromagnet is a solenoid with soft iron core. The arrangement behave as a magnet when electric current is passed through it. An electromagnet consists of an uninsulated an insulated wire coil around a soft iron bar. When current is passed through the coil, the whole system will behave like a magnet. This whole system will behave like a magnet. One end will be acting like a north pole, and the second end will be acting like a south pole. Okay, its magnetism disappears as soon as the current through the coil is switched off. Therefore, the electromagnet is a temporary magnet, not a permanent magnet. Along the current, the magnetism can also be switch off and switch on. So we can control the magnetism of an electromagnet. Depending upon the shape of iron core, the electromagnet can be either a bar magnet, okay, or it can be of U-shaped magnet. Let us make an electromagnet of our own with the help of activity number 4. To perform this activity, we need a meter long insulated copper wire, pins, an iron nail, a switch, iron stand, and sandpaper and battery. Okay, now what we will do? We will take a meter long insulated copper wire and wrap it around iron nail like this. Okay, we will wrap it around this iron nail. Okay, like this. Okay. Now we will scratch the free end of the wire with a piece of sandpaper and connect the two free ends of the copper wire with the battery so that electric current can flow through it. Allow the current to flow through the copper wire by putting the switch on. Okay, now bring the two pins near to the iron nail and observe what happened. Okay, the pin will get attracted toward the iron nail because the nail has become an electromagnet. On turning the switch off, the pin fall down, showing the electromagnetic nature or magnetic nature of the nail has disappeared as we are cutting the current supply. Understood? Next topic is factor on which the strength of electromagnet depend. The strength of electromagnet has been provided by the help of electric current. So we can increase or decrease it by controlling the electric current, right? So what are the factor on which the strength of electromagnet depends upon? The first factor is the amount of current which we are providing. Okay, which we are providing through the coil. If we are increasing the amount of electric current, then obviously the strength of electromagnet will increase and it will work. Okay, and if we are reducing the amount of electric current, obviously the magnetism or magnetic property of the electromagnet will be decreased in quantity. Now the next is the number of coil or turns of copper wire in a coil. We have already learned that we are coiling the insulated wire over a soft iron piece. Okay, so if this number has been increased, so the strength of the electromagnet will also increase. If the number of coil has been decreased, then the strength of electromagnet will decrease as well. The strength of electromagnet depend upon inversely upon its length, which means the smaller the length of the electromagnet, more will be the strength. Okay, means if this electromagnet is smaller, more number of coil will be fitted in the small size and the strength will be higher. Understood? Now what is the use of electromagnet? Just see over here. Use of electromagnet due to its temporary magnetic property or magnetic behavior. Okay, an electromagnet find extensive use in various industries and scientific devices as well. First, it is used to separate iron scrap. Just see over here, it is getting iron scrap is getting separated from the huge amount of junk. Okay, so to separate iron scrap from the junk in industry, we are using electromagnet. The second is doctor use very small but strong electromagnet to remove iron dust from the eyes. If your eyes are having some kind of problem in which there is a magnetic substance has gone as a dust, so it can be removed with the help of electromagnet. Okay, now third point is used in receiver of telephone and electric motors. Okay, electric motor is also working on the principle of magnetic effect of electric current. Now next is they are compulsory part of picture tube of television and computer screen. They help in the formation of image on the screen. Next, a number of electromagnets are used in a car which help in moving of different part and generate electricity as well. Next is they are used in relay switches. Relay switches. Relay switches allow a small current to switch a larger current on or off. Next is very strong electromagnets are used to carry the fast moving maglev train which run at a speed of 400 km per hour. It means it travel a distance of 400 in just a hour. It travel a distance of 400 kilometers in just an hour. Okay. Now next topic is electric bell. We have seen electric bell at our home or at our school as well, right? Whenever we visit our neighbors or our relative, we simply press the electric bell which is hanged at the door. Okay, this electric bell is made up of the following component. Just see over here the structure. This is how the electric bell setup is. Okay, now we will study about each part of this electric bell one by one. First we have to talk about the very important part of the electric bell, that is a U-shaped magnet. Okay, it is the U-shaped electromagnet. It is not a simple magnet. It is an electromagnet. Means magnetic property of this U-shaped electromagnet can be controlled by us by providing light and by switching off the light. Okay, this U-shaped electromagnet is present over here in which one end of the wire, it is coiled up with the copper wire, whereas one end of the copper wire is connected with the terminal T. You can see it is terminal T1. Okay, and it is connected with the one end of this wire which is coiled around the U-shaped electromagnet. Okay, and the other end is connected with a brass stud. You can see over here, this is the brass stud. Whenever the current is provided into this, okay, by pressing the button or by switching the circuit on, okay, so in this condition the current will flow and this U-shaped electromagnet will behave as a magnet. Okay, and if a substance behave as a magnet, what will happen? The magnetic substances will get attracted toward it, whichever is present in their magnetic field. Correct. So next is armature. Okay, this long strip over here which is connected with the brass stud is known as armature. Armature is soft iron strip which is attracted by electromagnet because it is, just see over here, it is present in the magnetic field of U-shaped electromagnet. Whenever it is magnetized, the armature will get attracted toward the U-shaped magnet. Understood? Now see over here, at the end of this armature, it is connected with the round shaped structure. This round shaped metallic sphere is known as hammer. Understood? It is basically made up of steel. It is attached to the armature at its one end with the help of soft, springy, thin metallic piece. You can see this is the metallic piece which is helping the armature to get attached with the hammer. Okay, the hammer strike the gong to produce sound. Now the question arises, what is gong? Just see over here, this is the hammer. Okay, whenever this armature will get attracted toward the electromagnet, what will happen? This armature will move in downward direction, and in this way this ball over here will get lowered down and it will hit this round structure, round sphere. Okay, and in this way the sound will be created. Just look at over here, the sound has been created by hitting the hammer on the gong. Okay, so this is gong. Gong is what? This is gong. Understood, class? Now next is gong. Gong is a big metallic hemisphere which is hammer or strike to produce sound. Whenever this armature will be attracted toward the Whenever this armature will be attracted toward this U-shaped magnet, electromagnet, this hammer will move and it will hit the gong and produce sound. Now the next is contact screw. You can see over here, this is what a contact screw is. Okay, this is what a contact screw. Understood? It does look like a screw and it is making a contact with armature. That is why we are calling it a contact screw. Over here you can see, over here it is having a connection with armature, right? Basically, the contact screw is also known as a make or break screw, which is adjustable. The tip of the screw is made up of silver cadmium alloy to prevent its oxidation due to sparkling. Okay, it is connected to the terminal T2. Just see over here, it is connected with the terminal T2. The wire is running through this one over here, and just see the T2 terminal is connected with the contact screw. Okay, now it is used to adjust the contact between the armature and the push button of the bell to produce best sound. Also, it can change the frequency of ringing bell. Understood? So that is why we are calling them contact screw. Now this is all about the structure of electric bell. Just see over here now how it is going to work. Working of an electric bell. Understood? Before understanding how the electric bell work, just look at the structure one more time. Just see over here. Now in this diagram, this whole setup is having what? A closed circuit. You can see from terminal to T2, it is running to the switch to over here to contact screw to armature to U-shaped electromagnet to T1. Means the whole setup over here is in closed circuit. Okay, in this condition, obviously this U-shaped electromagnet will behave as a magnet. Now see over here, what is difference in this second figure? See over here, this is the T2 phase. Okay, the minus sign which is indicated, it is T2 terminal. It is connected with the electric bell switch. Okay, it is switch. Now just see over here, it is running like normally, but the contact screw connection with the armature is broken over here. It means it is an open circuit. It means while working, the electric bell constantly change from closed circuit to open and from open to closed. Okay, just have a look how it works. First point, the terminal T1 and T2 are connected to a battery or energy source through push button switch. When the switch is pushed on, the current flow through the electromagnet and the contact screw. As a result, this electromagnet will get magnetized. Okay, as this electromagnet is magnetized, obviously it will attract. Over here, see, there is a difference between the armature and electromagnet. So whenever the push button is on, the current will flow and this U-shaped electromagnet will behave as a magnet. Okay, because the magnetic property of this U-shaped is based on the availability of current. So whenever the current will flow, this will act as a electromagnet. Now just think, what is the material in front of it is made up of? It is made up of iron. Iron is a magnetic substance. So whenever this U-shaped electromagnet will get magnetized, it will obviously attract the armature. Okay, and once the armature is attracted, what will happen? It will move in the downward direction and it will hit the gong. Understood? It will hit the gong, and in this way the sound will be created. Understood how the sound is being created? Understood? Now the hammer connected at the end of armature move and hit the gong and produce the sound. This is the way the sound is created. Just think now what happened. When the hammer is moving downward direction or when the U-shaped electromagnet has attracted the armature. The contact between the armature and contact screw is broken. It means now the circuit has converted into an open circuit. Understood? In this way, the circuit has converted into an open circuit. So, the attraction power of this U-shaped electromagnet will be vanished. And if that happen, with the help of lever, this armature will return back to their original place. It means it will return like this. Okay, and again see over here, contact screw is making a contact with armature. So and again the current will flow through the circuit, and again this U-shaped electromagnet will attract the armature, and from this diagram it will shift to this, and it will hit the gong, and again the contact will get broken. It means the circuit of electric bell is converted in from a closed circuit to open, and open to close, and then again closed to open. This will repeatedly done. Okay, this will be repeatedly done, and because of this the electric bell is having a tring tring sound. Understood? Clear? That this is how the bell work. This is how the electric bell work. Okay, class. Today class we will discuss question answers in our next video.